Greetings to my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to look at representational state transfer, also known as REST. We'll be discussing REST and RESTful API, RESTful implementation, URI, URN, and URL. We'll look at the anatomy of a RESTful request, and finally, we'll discuss RESTful API applications. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. REST is a framework. This framework we can use to create APIs that are going to be built for HTTP and HTTPS. You can access them through a web browser. You don't need special software. RESTconf is a REST-like API, so it's similar to REST. It's the API here, but we use it for managing and configuring networking devices over HTTP. We also use Yang for data modeling and netconf here for our defined data stores. REST and that RESTful API, it needs to use HTTP and HTTPS. The reason that's nice is most firewalls allow that port 80 and port 443 to go through them. And so if REST and RESTful uses HTTP and HTTPS to request that information, it's going to go through those firewalls. Now, this REST API, it has to work on top of HTTP. So you need to be able to have HTTP running. It's a set of functions your developers can use, and it performs these requests and it receives responses. So it's a two-way communication. They can request, so I request data from you, and then I get that data back. I will receive that data. Now, the idea of RESTful is conforming to the constraints of that REST architecture. There are certain rules to be part of that REST framework. In the three big ones here, it has to be a client-server environment. The client handles the front end, the server handles the back end. The client says, hey, I want some data. The server says, here you go. And the neat part about that is either end can be replaced independently. Then it has to be stateless, that no client data is stored on the server between requests. Once you make that request to the server, once that client makes the request to the server, that server responds, no data of that client exists anymore. That session state is stored only on the client. And the third one is it has to be cacheable. Clients can cache those responses to improve performance. There are several ways to make this REST API request. You can use your web browser, making an HTTP request right from that URL bar. You can use a command line tool like curl. You could use an application or a program like Postman. Or you could use a programming language like Python, JavaScript, and Ruby. RESTful APIs use an HTTP client-server process. They make a request, the client makes a request, that server responds with the data. There are several HTTP methods that are used for this. First one is the post, where we're going to create some data on the server. Through this post, you are creating data. It's new data being added. We can do a get, where you're going to read data. You're going to get data off of that server and display it in your browser. We have the put or patch, where you're going to put or update data on that server. And then finally, we can delete data from that server. So these four methods together are also known as the CRUD method: create, read, update, and delete. I hope you're liking this episode on REST. If you have the time, please leave a comment and let me know what you think about REST. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When you work on the internet, web resources, web services are identified using a universal resource identifier. Now, this is a string of characters that identifies specific resources on the network. There are two specializations of our URI. The first one is the Uniform Resource Name. What that is, it just identifies the namespace of the resource, the web page or the document, the image, whatever you're looking at, without reference to the protocol. So it's not saying it's HTTP or FTP. The second specialization of our URL is the Uniform Resource Locator. Now, this defines the network location of a specific resource, and it also tells you the protocol it's being used. Protocols could be FTP, FTP, SSH, HTTP, HTTPS. Here's an example. And this is for SFTP, Secure File Transfer Protocol. We say what the protocol is, then we give the resource name of it. There are several parts to the URI. The first part here is the protocol or scheme. This is the protocol or the scheme. Tells you what we're looking at. Are we doing HTTP, HTTPS, FTP? What are we doing here? Then we have our host name. This will get us across the internet. Then we have the path. That would be this part right here. Once we get to this resource on the internet, where is it located? Which also includes the document name here. Got to remember to include that. And then we have any fragments. This would be at the end. And so this will tell the web server we're specifically looking for page 155. So that is our fragment. Here's what a normal RESTful request looks like. It's similar to a URL, but it identifies a specific resource. Here we have the API server. It lists out our HTTP protocol and our server location. We have the resource we're going to access. This would be the API information that is specific to our server here. And then we have our query. This is your API query. And in this case, it's specifying the format, which is JSON. And then there's going to be a key, and that would be your public key or your guest key. It wouldn't say key, but it would be something else. And then the parameters which filter your query. And in this case, we're at MapQuest here, and we're trying to get a map from San Jose to Monterey, California. We're trying to get directions from here to there, and this needs to be in the parameters for this API query. A lot of RESTful APIs, they require this key right here. Now, the key is used to identify the source of the request, where the request came from. A couple reasons to do that. One would be to authenticate who is making that request. If you have to pay for that key, for that data, make sure that you're authorized, or at least just have an account on the system. Maybe you're going to limit the number of people that are doing that. Maybe the number of requests you're going to limit per key. You can also use it to capture data about who is getting your request and track that better. Or you could also use it to gather information on people using your API. To execute these commands, once again, we have several areas where you could do this. You could do it on a website. This would be built into your website. The developer would put it in there. You could use a program called Postman. And this is designed to look at and test RESTful APIs. You could program it into Python. Use Python to run that API, or even into a network operating system. Here's some of those examples. Here we have a web browser, and we're going to put our API request in there. And this is a URI. There is http:// at the beginning here. And then this is our server. Then you supply it with the IP address, and you want JSON data back on it. You hit enter, and this is the response you get back. Gives you an IP address and the host name and where it's located, the location, even a longitude and latitude. Who is this registered to? Cisco Systems. We can then execute this same API from the command line. And what we're going to do is use the curl tool here, provide the same URI right here to call the API, and you can see it returns the same information. REST API calls can also be done programmatically using JavaScript. Here I have a tool where I can put my code into one window and see the results in the other window. Here is the GET request with the URI. This is the JavaScript that's going to request it. Come up here, click on Run, and it will give us our information over here. We can do the same thing using Python. Here's that same API call, but this time formatted in Python, where we can execute this Python in this window here by clicking Run, and then the result is printed over here. It was my pleasure to provide you with this wonderful episode on REST. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.